the torque required by the cable to hold up a beam that must be elevated at a certain angle for some kind of architectural structure that you're creating, or you could even be an artist doing what they call work art or junk art. And you want to get an idea of what force in the cable is required to hold the beam at a certain angle. Well, if you're an architect or a civil engineer, you need to do that computation, and that computation comes to you in a physics class. Usually, that's where the first introduction comes. Or, you know, an electrical engineer needs to understand the principles of the creation of light in materials that conduct electricity, where you have electrons that are accelerating on a microscopic scale, and as they accelerate and change their states of velocity, they radiate. And the radiation can be a variety of frequencies. It can be infrared, which is the heat that you feel from the filament that has been heated up by the you know, copper wire and the current through it, or it can be light, which is visible radiation that occurs from the acceleration of the charges within the metal. So those computations regarding, say, power output or heat output are physics concepts that are introduced in your education. You'd be surprised at the number of formulas that you're going to be using in electrical, mechanical, civil, or chemical engineering that can be traced to some formula that you learned in a physics class at this level or at the high school level. So I don't understand why people think physics is irrelevant. They're doing physics when you take your engineering course. Half of the formulas in that book are coming from a fundamental physics computation. Ohm's law. You know, heat transfer laws, and the analogies that they have with other subjects. We, for example, use the analogy between the inductance and the mass of a particle to, you know, look at the inertia involved in the increase of the velocity, which can be analogized to the current in an electrical circuit. So if there's a rumor that physics has nothing to do with what I'm doing, then that rumor is false. Now, it could be that a lot of students in engineering don't necessarily want to discover or study all areas of physics, because their area of, you know, engineering only involves mechanics and statics and motion, and so why should I learn about heat transfer? Okay, that is true, but you may get a job that involves a team to build an entire building that has to incorporate all these elements. So you're going to be at meetings that integrate the various aspects of physics to get the final project done. So you have to be able to talk to physicists in different departments and find out how their specialty is going to affect yours. So, for example, you know, a person who is good with heat transfer would be a good person to talk to if you're a mechanical engineer that is looking at the structural integrity of a beam or component that will be heated up and may change its mechanical properties as a result of the rising temperature. So what seems to be irrelevant from your field may become relevant as you go into the world of work. So I don't understand that. I mean, maybe the problem is that the physics teachers are not connecting these things in a way that is comprehensible, so the students don't have a generalized interest in it. I try to do that, but like I say, the homework is great and the requirements are great, and so when you're under a lot of pressure, you become more cynical about how all of this is going to help me. Yeah.
And one last question.
Yes.
Well, what kind of suggestions do you have for us students here at Chabot? Not only for physics or math or engineering, for all the students here at Chabot, to keep on track on their studies?
To keep track on your studies, you really have to answer what are the distractions. So can you tell me what some of the distractions that students encounter that can cause them not to focus? And then maybe I can help you answer that question.
Well, maybe they don't have the motivation for it.
Okay, they don't have the motivation for it. That's an interesting question. If you don't have the motivation for it, then either pick a different field that is more interesting to you. That's one solution. The other solution for non-motivation is to maybe focus on things that are reducing your ability to enjoy the subject and reducing your motivation. Such as, for example, if you are working too many jobs and taking too many classes, your motivation will be reduced by the increased stress. So there can be what we call induced non-motivation that is induced by stress. There can be also inherent motivation that is caused by the person not being interested in the subject. Now, that's a question that you need to ask yourself. If you're not interested in science and science-related fields, why are you going into it? Many of the answers are, it is economically feasible. Well, that's motivation. Okay, so, I mean, in the worst case scenario, you don't like the subject, but you know it's going to pay the bills, so learn how to become motivated by it by reducing your stress, reducing the number of classes you're taking, to make the experience of taking the class more enlightening and more interesting and more enjoyable. So that would be my recommendation for the motivation issue. But physics and science and engineering is very interesting, and it can be a place where you can find motivation from it, especially if you realize that you can help the world become a better place. So let's say you know, you're working in environmental science, which involves physics, that involves, for example, dealing with the global warming crisis. Okay, the motivation may be to reduce global warming. That's a laudable goal to go through, to have, right? You want to reduce global warming. That should be the motivation. And the motivation would be to study the subject as a way to contribute to that. But if that's not your interest, and you don't like science, you don't like numbers, then try to pick a field like law that has to do with environmental. Some people are more interested in language and expression to solve the global warming crisis. I mean, there is no one way to stop the environmental crisis. There's many ways. We need different kinds of skills, from legal to scientific to other kinds of skills. So there's many ways to attack social problems and environmental problems, whether it's in science or outside of science. Okay.
Well, thank you, Mr. Alexander.
Okay.
Interview.
I appreciate that.
Thank you, guys.